Hey guys, we've got an implicit differentiation question here today where it's asking us to prove that if we implicitly differentiate this relationship here twice, we will end up with this relationship here. So basically this question is testing our ability to implicitly differentiate and to, well, let's see what it's going to ask us. Or let's see where the question takes us. So, first of all, what we're going to have to do is, by the looks of this, what we're trying to get the first relationship to look like, we're going to have to implicitly differentiate with respect to x. Okay, so what we're going to do is we're going to implicitly differentiate both of these with both sides of the equal sign with respect to x. And what we get is we've got a function. We're going to use the product rule. So we have the derivative of the front, which is 2x times the back, plus we leave the front constant and we times it by the derivative of the back. Now, if we've just got y here, the derivative of the back is just going to be dy over dx. Now, what we're going to do then is we're going to then minus the derivative of sine is cosine. And the derivative with respect to x of 0 is simply 0. Great. So we've got to the first part of our implicit differential unscathed. Well, that's a good start. So what we're going to do then is we can see that we have double derivatives in the final solution. So what we're going to do is we're going to just take the implicit differential again and see where that takes us. So with the first one here, we're going to use the product rule again, where we're going to have the derivative of the front, which is simply 2. Remember, we're taking these with respect to x, so it's 2y, plus the derivative of the back, and we're leaving the front constant. So it's going to be 2x dy dx, so that's the derivative of the back, and that's the front being left constant. So we'll put them in a little bracket for the time being, just so we can separate that this bit has come from this part of the equation. And now we're going to do this part of the equation. So we're going to add this to, we're going to use the product rule again. So we have the derivative of the front, which is 2x. And we're going to leave the back constant, so it's just times by dy dx. And we're going to add that to, we're going to leave the front constant, so it's just going to be x squared. And we're going to multiply it by the derivative of the back, which is just d squared y over dx squared. So the double derivative there. Now that's come from this part. And then what we've got is we've got this minus cosine of x, which we have to do the derivative of. So the derivative of cosine is negative sine. So minus cosine will be positive sine. So we're going to have plus sine of x. And again, the derivative of 0 with respect to x is still equal to 0. Okay, well, we've got a few of the same symbols that we have in our final solution in this equation here, so I reckon we're on the right track. What we're going to do now is we're going to get rid of the brackets and we're going to do a bit of grouping. So what we've got here is, let's keep the 2y. So we've got just 2y plus, now we've got 2x dy dx plus 2x dy dx is probably going to be 4x dy dx. Well, not probably, it will be 4x times dy dx. And then we have plus this x squared term. Times the d squared y over dx squared. Plus, now what we've got here, this sine of x. Now if you notice, we don't have sine of x in the solution. So we're going to have to exchange this for something. And what you can do is, if we look now, this sort of intuition is going to be based on you doing a lot of these different problems. But if we look back to the initial equation that we're dealing with, what we can do is we can take that, we'll just put it to here. What we can do is, we know if we took the sine x over to the other side, we could say that sine of x is equal to x squared y, by just doing a little bit of simple algebra. So if we have this relationship, what we can do is we can substitute that in for sine of x here. So rather than writing plus sine of x equals 0, we're going to write plus x squared y equals 0. Now we're getting closer and closer to this final sort of solution here. We need to put our x squared term in the front. Now with these sort of proof questions, I do look quite a lot at this formula we're trying to get to as a way of guiding myself through the problem. So now we have plus the 4x term. We have that 4x term, so we're just going to plus it. Then what we've got is we've got this grouping at the back. So let's just put all of our extrapates on the back of this relationship. And then what we can do is we can finally, if we factorize these last two pieces here, what we can do is we will end up with this. So that's that sort of light bulb moment that you have at the end of the sort of question, where you're going, oh, there it is. I can see the light at the end of the tunnel. So I then just rewrite the entirety of the relationship or the expression, and then I'm going to factorize these last parts by y. Now usually I put the y in the front of the bracket, but because in the question they've got the y at the back, just for a little bit of like sort of I don't know, so it goes through the whole problem, I'm just going to make sure that my solution or my final equation has the y at the back. And what we can see here is this matches this. Now, to solve a problem like this and be able to do it comfortably, there are a few hurdles that you're going to have to jump over. The first hurdle is being able to apply sort of the chain rule and the product rule to be able to implicitly differentiate functions like this of two or more variables. Now, what you have to be able to do is you have to feel comfortable with the algorithm of implicit differentiation, which if you do a couple of problems, it's like riding a bike. You're not going to forget it. Now, I would say that the hardest part of this problem, trying to get through it all, is like if you're in an exam situation under pressure, recognizing this step here where you've got this sine of x hanging on the end of your expression, and you look up to what you're trying to prove and there is no sine of x. So what the hard part is, or I would say the bit that's going to require the most practice to be able to develop this sort of intuition, is then recognize that, hang on, I've got sine of x in my original problem, and I can just massage this formula here a little bit to come out with a expression sine of x in terms of some other variables, which I can then substitute into my equation. So again, like most of the videos that I put up here, guys, it's going to take a few goes. Don't be daunted. It's not complicated. If I can do it, anybody can. Just keep practicing. If you have any problems, let me know. I'd be more than happy to help you guys out with any of your issues. But yeah, until next time, keep practicing, and I'll see you later.